Where is everyone? Only 6 of you? Come on. But anyway, thank you guys for being here on time. We are going to start log today, and most likely we'll be able to finish it today and start trig. I didn't post the trig notes yet because I'm still making them. Once I'm done making them, then I'll post the trig notes. And I graded your exam. Your exam, I will give them back somewhere in the middle. Once you're done with these, and when more people come. So for now, you can write down all these properties for log, and then I'll discuss them one by one. What's that recording for now? Well, log has some properties. You have to remember all these properties because the application is based on this. So the first property says when you have the base and the argument same number, they cancel out the log, so we get the results to be 1. Second property says when your x value is 1, the argument, then your y value is 0. And it's true because if you look at the log graph, it goes to the x value 1. So x-intercept for log graph, you see the shape. So when x is 1 or y is 0. This is what it says here. When x value is 1 or y value is 0. I mean here. And then log 0 doesn't exist because when x is 0, we have a vertical asymptote here. So there is no y value. The next one says log negative number doesn't exist. Log of the negative number doesn't exist because you see on the left side of the log function, there is no y value. So log 0 doesn't exist because it's a vertical asymptote. Log cannot take any negative number because there is no graph on the other side. And log 0 doesn't exist. Log 1, it means when x is 1, how much is the y value? It's 0. So log 1 is always 0. And except for that, any other cases when the base and the argument are same, then they cancel out the log, the result is 1. Then we have product rule. Product rule says when you have multiplication in the argument, you can distribute the log, but you have to add as a result. Because when you multiply something, you get something big. Similarly, when you add something, you get something more. So multiplication and addition, they go hand in hand. In multiplication, we distribute the log using addition. And in division, you can also distribute the log. You can think it's a distribution, but actually it's not. You can think log as a distribution in division and multiplication. In multiplication, you add the result. In division, you subtract the result. In other words, if you have a numerator and denominator, for example, log a, b, c over x, y, z, everything you have on the multiplication, everything you have on the numerator, they will get positive sign. So log of A plus log of B plus log of C. You distribute the log with addition sign, and everything you have on the denominator, you also distribute them, but they're going to have negative sign. So negative log X, negative log Y, negative log Z. The numerator, everything on the numerator as a multiplication becomes a separate log with addition, and everything on the denominator in the multiplication, everything as a multiplication on the denominator, the log gets separated with the minus sign. And then we have power rule. Power rule says if your argument has any type of power, then log its power, it always brings it down as a coefficient. So anytime your argument has any type of power, you cannot keep the power, you have to bring it down as a coefficient. And then says change of base. If you observe, most of the scientific calculator, they have only the word log or ln, like log or ln. When you don't have any number on the base, we have invisible 10 base. And ln has invisible e base. So these are the two default log and default natural log we have. Anytime you want to find any of the log, you cannot use most of the scientific calculator. For example, if you want to find log base 3 of 5, log base 3 of 5. Let's say you want to find this in a scientific calculator. Unfortunately, the scientific calculator doesn't have any base option. It has only log option. So in order to find how much is the log base 3 of 5, we have to change our base from 3 to the default base 10. So what we do is, we kind of like distribution, but actually it's not distribution. It distribute the log to the argument, and it divide by distribute the log on the base. So it will be log of the argument divided by log of the base. And in that case, the visible log 3 turn into invisible default log 10. And now you can use the calculator. Calculator will tell you the answer. So to make our life easier with scientific calculator or any other basic calculator that has a log or ln option, mathematician invented this method. It's called change of base. It means you're changing your base to whatever base given to you into base 10. And then we have inverse properties. The first one is same. Anytime you have a power on the argument, it has to come down. So you get x log base b of b. But the rule says if the argument and the base are same, they cancel out the log. So basically, you're left with x. The next one says, let's say you have multiple powers. Your base itself has one power, and the argument has another power. If the base and the argument are same number, you can cancel all of them out. And what you're going to do with the power is that you take the argument power, put it on the numerator, and you divide it by the power on the power on the base. So if base and argument have multiple powers and the base and the argument are the same number, then they cancel out the log. The result is power on the argument divided by power on the base. And then the last one says, if you have a number that has a power log, and that log has the same base as the number here, then all of them cancel out. You're left with the argument of the base, the argument of the log. Let me actually erase all of this so I can write easily. And then we have one last property that we use to solve logarithmic equation is one-to-one property. If we have same log with the same base on both sides of the equal sign with nothing extra, just two single logs, then we are allowed to cancel the logs and set the argument equal to one another. It's just like the exponential thing. If we have 5 to the x equals 5 to the, let's say 2, as long as you have the same base, you can cancel them and you set the power equal to one another. This one is same. As long as you have the same log with the same base, you can cancel them and then set the two arguments equal to one another. And these are all the properties you need to know for log function. Any question? Mm-hmm. Is that equal to log 5 by log 3? Mm-hmm. So arguments divided by base. You put log on each. Okay, let's use this to simplify few logs. Okay, we want to simplify log. It means do something so that the log will disappear. Now we have a log machine. In this machine, we are putting $100. How much money the log gonna give us back? That's the result we want to see. So we want to get a whole number or a number. We want to get a number without log. Now this log doesn't have any base, right? That means what is the base of the log? 10. Good. Anytime you want to simplify a log, you want to have the base and the argument same number. Only then you can cancel them. So that means we want to rewrite. So we are given log base invisible 10. We want to rewrite this as 10 to the some power. Is it possible? What is 100? 10 to the what power? 2. And then we can use this property. If the base and the argument are same, then they cancel out. So there is no more log base 10. The result is whatever we have on the exponent, 2. That means this whole thing is just number 2. It is written in different fancy way. So who knows the answer for B? Also 2. Because the 3 base, log base cancel out. What is log 100? 2. And why it's 2? Because we have 100 as 10 square. The power is the answer, not the base. Joanna, no phone. Ready? Okay. Let me rewrite this for you to make it look nicer. We have log base 3 and then the fraction 1/81. And the next one says 3 log base 3 of 4x. And if you want, you can put a parenthesis to make it look nicer. So, what do you think?
The first one you could rewrite, right? All 3
1 over 81, can you rewrite with some power? -4, great. 3 to the -4 is 1 over 3 to the +4, which is 1 over 81. Makes sense. See, the power rule says if the base and the argument are same, then they cancel out, the power is the answer. So let me show you both methods. Method 1. We rewrite log the argument using the base. So 81 is 3 to the power -4. If you do that, then the 3 log with the base 3, they cancel out. And our answer is -4. That's one method. Or you can use second method is this. We have log 1 over 81 in the base 3. See, in division, we can distribute the log with a minus sign. So log base 3 of 1 minus log base 3 of 81. What is log 1? The base doesn't matter. As long as it's c, x is 1. How much is the y value? 1. No, 0. See, here the log graph, when x is 1, or y is 0. So this is x equals to 1. So log 1 is always 0. And 81, we know it's 3 to the power 4. So 3 log base 3 cancel out. You have 0 minus 4. The answer is -4. Whichever method is easier. If you use that method, it's 1 line everything. And if you use this, it's 3 to 4 lines. Okay, how about the next one? 3 to the power log base 3 with argument 4x. 4x. This is same as this one. If you have a number that has a power with the log, and that log has the same base as the number, all three things cancel out. Whatever remains, that's the answer. So anytime you simplify any log, all you have to do is use all the logarithmic properties. Any question?
Well, it's at the power click in front, right? Why did that work?
Let's see. Insert. So we have 3 log base 3 of 4x. And this is same as 3 3 log base 3. 3 to the power. Okay, let's say this is y. Now, if this is y, then what happens? Log base 3 of x, y. It's y. And y. How do you prove this? 3. Okay, if we apply another log, I actually don't know how to prove this. I can find it out and then we'll let you know tomorrow.
Well, if you think so, log is the power.
3 log is the power, right? But it moves to the front only when you have a log.
Take the log of the whole.
Oh, I see. So this one, we apply, if this is equals to y, and if you apply log to both sides, so this whole thing is a power now, it comes down. So we get log base 3 of 4x, and then log 3 equals the multiplication. And let's say applying log 3 again. Log 3 and then log 3 of y. Now, in multiplication, log 3. Oh, so this thing, log 3 base 3, it turns into 1, right? So we have log base 3 of 4x equals log base 3 of y. And then you have a single log, they cancel out. So we have 4x equals y. The answer. Cool. Okay, let me rewrite everything. You don't have to know these rules. He just asked me why this is true. So I can show you why this is true. Okay, so we start with log. We have 3 log base 3 of 4x. Suppose this is y, because we want to know how much is this. We are looking for the y. Now we can apply log base 3 to both sides. Just like remember when you solve for exponential function, if we have e to the 5x equals less than 7, remember how do you solve for x? We apply ln to both sides. So you can do the same thing here. We can do the same thing on both sides. So when you apply log, now for log, this thing is the power. That means this comes down as a coefficient. So we have log base 3 of 4x as a power. It comes down, and we left with log base 3, which we applied of the 3 we have. On the other side, we have the same thing, log base 3 of y. Now this thing, as long as the base and the argument are same, they cancel out, turn into 1. So basically, we left with log base 3 of 4x equals log base 3 of y. We didn't multiply, applied. Log never multiplied to. Log is applied, it's a machine. So you applied. I applied log to both sides. When you applied log to both sides, now this 3 is the argument, and that thing is the power of 3. And the power rule says anytime log has a power, it has to come down as a coefficient. So this base 3 turns into argument 3, and the power comes down in the front. And now we will left with log 3, which we applied of the base 3 from before, which now is the argument. Now, as long as these numbers are same, they come into 1. So we left with the power equals the right side. And then we apply 1-to-1 property. When we have one single log on both sides of the equal sign, they cancel out. So there is no more log base 3, and we left to it. 4x is the answer. You don't have to know the details, it's just why it's true. The power. 3 has a power log.
So adding log is what makes it times log.
The rule is simply says when the number and the log base has the same number, then all three things cancel out, log base and the log base 3, and then all the base. The argument is the result. So this one. You have to memorize them if you don't want to know why they're true. Just memorize.
Or change things or try to get things and you have to know steps.
You don't have to know these steps.
I think like what you're saying is like, all right, imagine it was 3 log 4 to the 4x, then you would have to know these things.
Imagine what log?
If it was 3, and the power was log 4, not log 3, just 3.
Oh, only 3.
In the power of the, I'm just using an example, like log 4, so it's not the same
Mm-hmm.
base. And then you would have to know how to
Mm-hmm.
go down.
So see, this is base 10, so you cannot cancel them. Mm-hmm. But for this class, you don't have to worry. But in future, in real life, maybe we'll see them. But in this class, don't worry about it. Okay, 2 more. Figure them out. Simplify the log. How about the last one? Neighbor, no fun. Ready? Okay, besides Marco, who'd like to volunteer for the first one? Joanna. Mm-hmm. -3. 1/1000 is same as 1/q, and this is same as 10 to the -3 power. Great. And then what happens? You rewrote, so what's the answer? -3, because we have the invisible 10 here. So everything cancel out. The exponent is the answer. Great. The last one. Gabriella.
So, fifth root of same as e to the 1/5.
So ln of e to the 1/5. E and ln cancel out. Perfect. Good job. Got them. So in the exam, I'm going to give a few of these to test your knowledge about all the power. And in the final exam, definitely have to know the multiplication, division, power, and change of base. There will be one or two questions here, and definitely one question from here. And you're going to use these two definitely to solve logarithmic equation. So you're going to remember this because log doesn't always exist. So you have to check your answer. And this thing we need to solve logarithmic equation. We actually need all of them for the final exam and definitely for the exam. Okay, now about logarithmic graph, I believe. Oh, expanding the log. So when you have a single log given to you, we want to expand it with more log. So in order to expand log, we separate the log based on the argument what we have. The multiplication always on the numerator, we separate them with addition sign, and everything on the denominator, we separate them with the minus sign. That's all you need to know. Separate them depending on their position. Numerator gets positive when you distribute the log, or the denominator gets negative when you distribute the log. For example, here we have log base 2 with all of these things. So we have 1, 2, 3, 4 factors in our log. That means we are going to write log 4 times log base 2, log base 2, log base 2, log base 2. 4 elements. How number of elements means number of log. Now the numerator we have 2 and x. So we are going to add them because they're on the numerator. On the denominator, we have 3 and y squared. So we are going to subtract them. 3 and y squared. And then you cannot leave any power. So that means we have to bring these 2 power down as a coefficient. And also you have to apply the rule for same log, same base and argument. So what is log base 2 of 2? 1. And here 2 comes down as a coefficient. So we have plus log base 2 of x minus log base 2 of 3 minus 2 times log y base 2. Thank you. And that's all. Instead of writing one single log, you write multiple logs based on the elements you have, number of elements you have in your argument. And definitely this type of question will be in the exam. And in the final exam. The final. Oh, I should make this green. How can we rewrite square root of z as a power? 1/2. One more. Moving on, no phone. Okay, except Marco, who would like to try the first one? Go ahead. The log for W x cubed divided by y square and z to the 1/2. Okay, and then minus 1/2. Great. And then move 3 as a power, so it becomes 3 log x. 2 comes down. We have 2 log y. 1/2 comes down. We get 1/2 log z. And we just have log of 4 plus log of w. Great. That's what we have to do. No math is needed. Now, including Marco, who'd like to try the last one? I mean, not the last one, the next one. Gabriela. Log 5. 6 log w. 1/3 log x plus 1. So this thing is x plus 1 to the 1/3 power. Okay, next. 7/2 log y. Wonderful. So what is happening on the denominator is this. We have individual power, y to the 7, z to the 5. And we have a combined power square root that turns into 1/2. That 1/2 we have to distribute to individual power. So it becomes 7/2 and 5/2. And then we bring down all the power as a coefficient, and we keep our base as arguments. So I expect to see this type of complicated level in the final exam, and definitely in the in-class exam. Question? Okay, last one. Easy one. Well, this is Z. It doesn't look Z, but this is Z. Oh yeah. Oh. But this is the easiest one. 3 ln of E 4 ln of X. Perfect. And then you have to simplify wherever possible. E and ln cancel out. That's it. So you always have to simplify to the fullest. And the next topic is the reverse version. If the extended version is given, you have to write them as a single log, just going backward. For example, here, we have the expanded version, means we have multiple slug. We don't want to see multiple slug, we want to see a single log. So based on the sign, we put them together. Every plus sign goes on the numerator, every minus sign goes in the denominator. For example, let me actually put one more thing here. Let's say, where is my sign? Minus log of 7. Okay. So first of all, we cannot have any coefficients. The coefficient turns into power. So we'll move this 3 here as a power. We are going to move this 2 here as a power. So we have log of x minus log of y plus log of z squared minus log 7. Log x cubed, thank you. And then instead of writing 4 logs, we are going to write only a single log, a big log with a division sign. Now, every log has a plus sign, the argument goes on the numerator. Every log that has minus sign, the argument will go on the denominator. So x cubed, what sign we have in front of x cubed log? Here, what sign we have? Addition. So the x cubed must go on the numerator. Now for the argument y, What sign we have in front of the log? Minus. So where the y should go? The numerator or on the denominator? Denominator. And then the next one is z square. What sign we have in front of z square? So where should z square go? Numerator. And how about the last one, 7? Denominator. And that's it. We rewrote multiple logs into a single log. You can write y7, but it looks weird. So I wrote 7y. Any question? Yeah, but it cannot have a negative power. You always have to have everything positive. Okay, for the next one. It cannot. Why is it denominator? Or the previous one? The minus one is it's to the bottom. So this is actually same as ln of EQ x to the 4 divided by y to the 5. This is what you have. They are same. The negative means it's on the denominator. Okay. Combine. Well, let me give one more. Minus. This is minus ln of A, B, C, D. Okay. Ready? Michael. A to the 8. To B plus 1. C to the 3rd. And then D. Good job. So in an exam, you're definitely going to have one expanding and one single log. So this one says that is a single log. Anytime you see the word single log, means like one log and put everything in your argument. And when it says expands, it means you want to see multiple logs, not a single log, but many, many logs based on number of elements you have in the argument. Okay. Question? So this is one finalized topic. And then the next finalized topic is change of base. Like I said, it says find this, and you're going to use calculator. And you're only allowed to use scientific calculator. Most scientific calculator doesn't have any other base, any other log besides base 10. So how are you going to find this in your scientific calculator? Well, change of base. Change of bases. The argument is a little bit at the top, so you're going to put the log of the argument on the numerator. And you see base is on the bottom, so you're going to put this on the bottom with your base. And then you can take out your scientific calculator, punch this in the calculator, it will tell you the answer. So even if you have a phone for now, you can use log in the scientific version. and it says round to the nearest hundredth. It means how many decimal place after the decimal? 2. Right. And in your exam, you have to show me this change of this, here, this one, this line. And then give me the answer. And be very careful when you punch in this one. Anytime you click on log, this is already built in. But this one, you have to put. So make sure to close your parentheses. The left parenthesis is built in, but the right one is not. So you have to close the right parenthesis by yourself. Otherwise, the calculator will read log differently. Okay, who has an answer? How much? 3.8. Before rounding, tell me the answer, and then we're going to round together. 3.834. So 3.83. Is she correct? Great. The next one. You're done. 5.36. The next digit, 0. So 5.36. So what did you do? How did you find it? ln 361 divided by ln of 3. Now let me show you something cool. So every scientific calculator has both of them, log and ln. Now, if you punch 361 log, it's 2.557, right? If you punch in 361 ln, it's different, 5.88. If you punch in 3 log, it's 0.477. If you punch in 3 ln, it's 1.09. So all 4 numbers, they are different from one another. You see, all of them, they're different from one another. But then, observe. Here, Hector used ln. So ln 361 divided by ln 3 is 5.36. Now, what if I don't want to use ln, I want to use log? So I have 361 log divided by 3 log. Our answer is same. See something cool? All the answers are different. The log and ln individually, they are not same. They give you different results. But somehow, if you divide them, the results are same. I don't know why. By something proportion wise, they are same. Individually, they're different pieces. But if you put them together, proportion wise, they are same. So don't assume that ln 361 and log 361 are same thing. They definitely are not same. That's why we have E must apply ln, because E and ln, they are inverse of one another. But log and E, they're not inverse of one another. Log and E, they don't cancel out. For example, let's see, E ln is 1. See, E and ln gives us 1. Do you get the same thing for log? E log? See? E and log, they don't give you 1. Only E and ln equals to 1. So anytime you have E and you want to get to the base E, you must apply ln. And if you have ln, you want to get to the ln, you must apply E, you cannot apply 10. For example, 10 log is 1. But how about 10 ln? Not 1. See? So whatever is given, if you want to get rid of that, you have to apply its inverse, direct inverse, not other things.
The way you, like, I'm understanding to apply ln, but then applying E is just multiplying it as a coefficient.
You don't apply E, you base E. Oh yeah, you put power, you put base E. So E is a base.
Let's say you have
but ln is not a base.
You have ln 361 and you want to get rid of the ln.
You apply E as a base.
The base. Okay.
Not don't multiply. Because E is a base. It's exponential. What does exponential means? Something to the power variable.
You show us an example of you like something simple.
For example, insert. Let's say we have ln of 5 equals x. Ln of 5 equals, no, the other way around. Ln of x equals 5. And you want to find what is x. So you're going to apply E as a base, not multiplication, because E is exponential. Exponential means say exponential base with a power variable.
X is equal to E.
This is one way of thinking. The other way of thinking is this. If I told you we have log x equals 5, how are you going to solve the x? See, we have invisible 10 here. So you convert this into exponential function. So 10 to the 5 gives you the argument. So we apply the same rule here. This ln has invisible E base. So you convert E to the 5 is x. So either you can convert this way, or you can simply put apply E as a base on both sides. But you can never multiply. It's not E times 5. It's E to the power 5. And we are going to do this next. So we learned all about the last thing. Actually, no. The second last thing we should know is how to solve logarithmic equation. So our next step is logarithmic equation. And remember, when you did solving exponential equation, there are 5 types of exponential equation. Similarly, for log, there are several types of logarithmic equation. Based on the equation given to you, you take different approaches. Now, in order to solve logarithmic equation, the two main things we're going to use is converting logarithmic to exponential and the one-to-one property of the log. So we use the first one when we have a log on one side and just a number to the other side. We don't know how to solve log, so we convert log into exponential and we solve. And we use the second property when you have a single log on both sides of the equal sign, we cancel down and we have the argument. These are the main two properties we need in order to solve logarithmic equation. And log is a very dangerous function or machine. It doesn't always give you something real. Why? Because see, log 0 doesn't exist. So anytime you get an answer that makes the argument 0, you cannot have them in your solution. Or log negative number doesn't exist. So if you get an answer and if you substitute into the argument turns into negative, we cannot accept those answers. That's why exponential function, they don't have any problem. We accept all the solutions. But for log, you must check the answer. Exponential function exists everywhere because the domain is everything. See the graph of the exponential is this. So we can apply every x value in our exponential function. It doesn't have any problem. But for log, it's different. Log has a limited number in our domain. We can only apply all the numbers that is one side of our asymptote. So you always have to check the answers we get. Are they the correct side of the asymptote or are they on the different side of the asymptote?
Base y equals log x if the asymptote is 0.
So for exponential, we have y equals 0 horizontal asymptote. And for log, we have a vertical asymptote, x equals 0. So that's why our domain is not entire number line. It's a part of the number line. Okay, so now type 1. We have 4 different logarithmic types. For exponential, we have 5. For log, we have only 4 different. The first one is only one log on one term and number on the other side. For example, something like this. We have one log term on one side and number to the other side. In order to solve this type of question, we're going to use the first form, convert log into exponential. So just the example we did, you have two choices. Either apply E as a base on both sides, or already assume that we have an invisible E here. So you are going to convert this logarithmic form into exponential form. So the base gets the right side of the equal sign as a power, and we said that equals to the argument. It's like a cycle. When you convert log to exponential, you follow a cycle starting from the base. And now we know how to solve for x, right? What is our first step to solve for x? Add 3. And then the last step, divide by 2. So we have x equals e to the 6 plus 3 divided by 2. You punch in a calculator and round to nearest tenth. Tenth means how many decimal places after the decimal? 1. $200. 23.24. 204. 214. So 223 or 203. So 223. Simply give me the number. Okay, next time. My brain doesn't work when you tell me the number in details. Okay. 203.2. And sometimes they'll ask you what number you have in 10th place, what number you have in the 100th place, or in the 1000th place. So first you write down the entire number and then you see what number you have. For example, here it says what digit you have in the 10th place. Means what digit you have on the first place after the decimal. It's 2. Any questions? Okay, 2 more. Do I have more? Nope. 2 more on type 1. So remember, single log on one side and number to the other side means rewrite in exponential. Ready? Malvina, first one. 2x equals e to the fifth. Perfect. So doing a cycle. So what is x? Divided by 2. 207. So rounding to the nearest 1,000 means which place? Third place. So before you round, can you tell me what was the number after 7 or before? 5. Okay. So round 74.27. Great. Okay, who would like to try the next one? It looks complicated, but actually it's not. Marco.
Is, put it to base 10
Mm-hmm.
and plot the ball.
So 1 over x plus 1 equals 10 to the negative 1.
-1 to 1%.
So x plus 1 equals 1 over 10.
Multiplied by x plus 1.
Multiply by x plus 1.
And I got 1 equals x plus 1%.
X plus 1 over 10. Multiply by 10. X equals, how'd you get 9? Oh, because 10 here. Come on. So -1, x equals 9. I have to restart, so give me 1 second. So we have 10. So x equals 9. And then you have to put it here to see, does it make our argument negative? So we have 1 over 9 plus 1, which is 1 over 10. We are safe because our argument is positive. You just have to check the argument. As long as the argument is positive, I'm happy. Okay, the next one. We have 2 log on one side and number to the other side. Or multiple logs. You have multiple logs on one side and number to the other side. In that case, we have to first convert all the expanded version of the log into a single log. Why? Because when you have a single log, we can convert that into exponential form. So multiple logs on one side and number to the other side means combine the log and then do whatever you did in last two examples. And you have to remember, anytime you have log 0 or log negative number, they don't exist. So you have to check your work. You have to check your final answer. So in this example, we have log base 4 of x plus log base 4 of x minus 6. So we have multiple logs on one side. Is there any way we can combine them into a single log? How? How do you get 2x minus x? How do you get 2x? How do you get 2 squared? 2 squared is x squared. Remember, when you addition, you multiply the argument. In other words, in the expanded version, see all these examples we did here. When you do multiplication, we separate the log with plus sign. So we are going the reverse direction. We are going the plus side with multiple logs. So when you combine them, we are going to multiply the argument. If you have a minus sign, you divide the argument. So here we have a plus log. That means you're going to multiply the argument. So it's x times x minus 6. And now we have a single log position, single log situation. So we can convert this into exponential. So we get 4 squared equals x times x minus 6, which is x squared minus 6x equals 16. And now it becomes near normal polynomial. So how do you solve quadratic equation? It's a quadratic equation. Minus 16 x squared minus 6x minus 16 equals 0. And then factor. Can you think of two numbers multiply to 16 combined to 6? 8 and 2. What sign 8 must have? Negative. That means 2 must be what? Positive. Great. So from here we get x minus 8, 0. That gives us x is 8. And from here we get x plus 2, 0. So we get x equals minus 2. Just because you got them, it doesn't mean you can accept them. You have to check. So we have x and x minus 6. When x is negative 2, this one becomes log negative 2, doesn't exist. So we cannot accept this one. Then you take the other one. Can you accept the other one at least? When x is 8, we get log 8, it's safe, positive. And we get log 8 minus 6, which is log 2. This is also safe. So we accept x equals 8. You have to check the entire equation if they are left side equals right side. At least for this class, checking the argument is fine. And see, that's why you always have to check. Because we cannot have log 0 or log negative number. Any question? I will, after a bit. Okay, for the next one. See, almost done. Once you're done with this, then I'm going to give you exam, give you 5 or 10 minutes break, and then we are going to start trigonometry. Execute the two-step trigonometry. Oh, and in order to combine your log, there is one condition. Your base has to be same. If you have multiple bases, it cannot combine them. So we have log base 2, log base 2. The bases are same, so we can combine them. Okay. Let's get that. Right? Ready? Not yet. Okay, who would like to try this one? Hector. Divide. Good job. So minus means you're dividing. Addition means you're multiplying. Equals 1. Exponential. X plus 3. X plus 3. X plus 3. So 1 minus x is 2x plus 6. So add x. So you can actually subtract 6. So we get 1 minus 6 negative 5 equals 3x. Right? Did you make a mistake? No, right? So what is x? Negative 5 over 3. Did you check? Just because you have a negative, it doesn't mean you can ignore. You actually have to check whether this one works or not. So we have 1 minus x, means 1 minus 5 over 3. So 1 plus 5 over 3 is positive. So first one is safe. Now the second one, we have negative 5 over 3 plus 3. So we have minus 5 plus 9 over 3. You multiply 3 times 3, 9. You add and you subtract the minus 5. So this is 4 over 3 positive. You see, you accept it. Just because you have a negative, it doesn't mean it's automatically invalid. The number can be negative. The argument cannot be negative or cannot be 0. Even x equals 0, we can accept. Because 1 minus 0 is 1. It's a real number. It's valid. So the log cannot take any 0 argument or negative argument. That's the condition. Okay, I'm going to ignore this one. Let's go to the third type. The third type, we have single log on both sides. As long as they're single without any coefficient, anything added or subtracted, we can cancel both logs. So what's wrong with this question? Can you just cancel the log? Even if you divide by 2, it ends up getting to the left side. What can you do to get rid of the coefficient 2? In order to cancel them, they cannot have anything on the left side, cannot have anything on the right side, the logs. So you have to move it up as an exponent. The log of negative 2x equals log of x plus 1 squared. And now we are happy. We have single log on both sides of the equal sign without anything on the front or anything on the side. So we are allowed to cancel them. So we can only cancel single logs, okay? We cannot cancel log with something extra, log with their bodyguards. So we have negative 2x equals x plus 1 squared. And square means you're multiplying the same thing twice. So we have minus 2x. Who knows what do you get on the right side? Good job. X squared plus 2x plus 1. And then what do we do? Add 2x, add 2x. So we get 0 equals x squared plus 4x plus 1. Did I pick a bad example? It is not factorable, right? So probably it's a calculator question. Quadratic calculator. You go to the calculator, calculator. You get the x-intercept. It means since it's not factorable, you have two choices. Either use quadratic formula to solve for x, or use complete the square. I don't use complete the square because I have a whole number, even number. Okay, so complete the square method. In complete the square method, we rewrite x squared plus bx as x plus, I should rewrite this nicely on the bottom. We rewrite as x plus half of b squared, and we subtract half of b squared. So we can rewrite this thing as x plus, what is half of 4? You always subtract, always. So half of 4, 2. So we do x plus 2 squared minus half of 2, half of 4 is 2 squared. And we have plus 1 equals 0. This is complete the squaring method. You just rewrite the first two terms in 3 times using double squares. And then we get x plus 2 squared minus 4 plus 1, 0. So x plus 2 squared minus 3, 0. And now this one is nicer. So if you want to get it x alone, which one you get rid of first? The 2 from the inside, the square power, or the negative 3 from the outside? So we add 3. We get x plus 2 squared equals 3. And then square root. So x plus 2 is plus minus square root of 3. Last thing is subtract. So you get x equals minus 2 plus square root of 3, or minus 2 minus square root of 3. And then we accept only one of them. Square root of 3, is it bigger than 2 or bigger than smaller than 2? How do you know? We want to look for square root of 3 without using calculator. Let's say without using calculator. So approximately how much is this? It's 1 point something. Definitely smaller than 2, right? Do you know why it's smaller than 2? Because 1 is between, 3 is between 1 and 4, right? 1 is a perfect square, 4 is a perfect square. So if you want to find what is square root of 3, take the square root of all 3 terms. This is 1, this is 2. So all the number between 1 to 4 must be 1 point something. 1.1, I don't know, 1 point something. So we have x equals minus 2 plus 1 point something. What's the result? Minus or plus?
No, minus.
Minus 2. So minus is bigger, then so it'll be minus. The other one, x equals minus 2 minus 1 point something. So what's the result? Minus. Oh, man. So this is definitely smaller than 0 point something, right? Minus 2 plus 1 is definitely smaller than 1. 0 point, let's say 1. Okay. And this is definitely negative 3 point something. Because we have negative 2, negative 1s, definitely negative 3, and then more. Now what happens here? We have minus 2x, and the other one is x plus 1. So minus 2 times minus 0.1, positive, this is safe. This is minus 0.1 plus 1, positive, safe. So this one is safe. Now how about minus 3? Negative 2 times negative 3 is positive, so this is safe. But this one, negative 3, positive 1, is this safe? No. So answer is the first one. Minus 2 plus this one, and we disregard the other one. In the exam, they will give you something nicer, where you need a calculator to work with. But even if you bump into some type of question like this and you don't have a calculator, let's say calculator is out of batteries, and no one gonna lend you your calculator. So how are you going to solve this? That's how I find them out. So this is a bad example, but the next one is a good one. So solve the good one. Do you have a good number at least for the next one? Do you have a good answer? Okay, so let's do it together. What did you do, Marco? We can cancel them because they're single log without anything extra. Minus x minus x. X equals 2. Do you accept or do you decline these two? X plus 6 is 2 plus 6 positive, it's good. 2x plus 4 is 2 times 2 plus 4 is positive, good. As long as they are positive, we are happy for now. Okay, now the last type. What if we have multiple logs? If you have multiple logs without anything extra, you cannot have any number or any variable plus or minus. If you have anything extra, just log, 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 then what do you do? How? So the multiple logs combine into one log. So how do you combine them? Multiplication or addition? Addition, subtraction, multiplication, division. Which one? Multiplication. So you multiply the two logs. X times x minus 3. And this is log base 2 to the 4. And then you have two choices. Convert the right log into a single number, which is possible, or simply cancel them because they are the same thing. Log base 2, log base 2. So we get x squared minus 3x equals 4, and now it's quadratic again. So how do you solve quadratic? First, you have to subtract the 4, and then factor. X squared minus 3x minus 4 equals 0. So is it factorable? Minus 4 plus 1. So this one gives us x equals 4. This one gives us x equals negative 1. Do you just accept them? You must check before accepting anything. So in the exam, there could be multiple choice. And if you pick the multiple choice with both of them without checking, it's 0. Because just because you see them in the multiple choice, it doesn't mean they're going to work. You have to check whether they will work or not. So we have x and x minus 3. When x is 4, we have 4, 4 minus 3, both are positive, so you're happy. When x is the minus 1, the first one is minus 1, so automatically we cannot accept the negative 1. So only answer we accept is x equals 4. Some question you accept all the solution. Some question you cannot accept anything. So you have to check, always check. It may have one solution, may have two solutions, or may have no solution. Okay, the last question. It's a good time to give you that song back. So let me give you that song, and I will give you a little break. I don't know what is that. Should we start three? Or should we just cover a few questions from that song? I'll post a solution of that one later. Christian. Rachel. Moving on. Um, this password. Okay, so I'm going to give you 10 minutes break. You can talk to your neighbors, everything. Think about your complaint, even if it may not going to work. But still, if you want to complain anything, you can think about them. And then I'll be back.
It's the same thing. 50, I got 12. Yeah, it's 49.
You're telling me now. The PPS is that most
Yeah.
Oh, okay, I need time for that. Okay. I can see it. So here it becomes changing. Next time, show me something. So the main problem is to use lower level together. It's not cool. Well, I think that's all. And why do you push that? Oh my God. Right? Let me see what I do.
So Marco, I did not give you one more point because I wanted you to be more less confident in the next exam.
Last one.
I wanted you to feel less confident in the next exam. Because if I give you 100, it's like, oh, I got 100. And then you may not be so attentive in the next one. So I took off 1 point so that, the next time will be harder. That's like, it's for your own good. Okay, so I'm going to post the solution for the answer for the exam. And if you find any discrepancy in the points, I make mistake, So if you find any mistake in the points, let me know tomorrow. And also always show me your thinking process. Just because I give you multiple choice, it doesn't mean you just can circle one. Okay. Show me why did you circle that? If you guessed it, it's no point. But if you know why you circled it, show me the proof that you know, or at least show me how do you know that should be the correct answer. And what else? This week, Thursday, you have a quiz. Most likely it will be on trigonometry. And log, I'll think, should I give you log or should I give you trigonometry or should I give you combination? I'm going to think it. We still have 3 more days. And then next week, Thursday, you have your exam 2. Okay? And then the following week, you have your final exam. So all the homework, today is Monday, right? So chapter 1, chapter 2, homework due by tonight, midnight. And then you have chapter 3, we are done with chapter 3. This is chapter 3. We are going to start chapter 4. And then next week, you have chapter 3 homework due next Monday. And I would recommend you to start working on chapter 4. The last day to submit any of the homework is the 5th week Monday, which is that next Monday, but the following Monday. Chapter 1, 2, 3, 4. 1, 2, 3, 3, 4, 5. 3, 4, 5, July what? 6, the last Monday. Okay. I will definitely not gonna open any of the homework after Monday because we have only Tuesday and Wednesday. If final exam is Thursday. There is no point of doing the homework if you fail the final exam. So the last 2 days, no homework, nothing. Only concentrate on the final exam. We are going to do review here. We'll see. If we cannot finish everything by Monday, then we are going to do more materials on Monday, Tuesday, and review on Wednesday.
But I think we'll be able to finish everything because we are going to start trigonometry. And this is our last thing, trigonometry.
4 and 5. Okay, so who is the answer for this one? Gabriela. Tell me your steps. Mm-hmm. So first you combine them and then you can cancel. So x times x plus 3 with the log equals log 40. X squared plus 3x equals 40. Minus 40 equals 0. X plus 8, x minus 5. 5 times 8 is 40. 5 minus 8 is 3. So x is negative 8 and x is 5. Now this negative 8 makes this log negative, so you cannot accept this. And then 5, you still check. Check. We have 5 plus 3, 8, okay. And 5 is also okay. So the only answer we have is x equals 5. Actually, we're going to start trigonometry tomorrow. Let's do one application of the log. And there's only one question. Even in your homework, there's only one log question. So log, I don't know why we don't have any application in the book. But this is a finalizing question also. The population P of a village, T years after the village is founded, is modeled by the logarithmic equation. P of T means population. So P of T represents population. T means time, which is years after founded. And then we have this equation 34 ln of t plus 520, and t is bigger than 1 or equals to 1. How many years after the village is founded will the population be 550? What is this 550? Is it T or P of T? P of T, the population. See, population B 500. So we know P of T is 34 ln of T plus 520. P of T represents the population. So we have 550 equals 34 ln of T plus 520. And then you just solve for T. So step 1, which one you get rid of? 34 ln or 520? How? Subtract. Good job, 520. So we have 34 ln of T equals 550 minus 520, 30. Now next step to get the T alone. What is our next step? It's 34 times ln of T. Divide. It's times, right? Here, times. So they cancel out. We have ln of T equals 30 divided by 34. And now the last thing to do is we have invisible E here, right? So convert this into exponential. T equals what? E gets the power 30 over 34, and we set it equals to T. So you go to calculator and find out what is E to the power 30 divided by 34. Ln has invisible E power. Sorry, Ln has invisible E base. So you can say apply E to both sides, or just rewrite logarithmic into exponential format. So here's an answer. 2.416, round to the hundredth. 2.42. Yep. And that's the only application I found in our exam or homework. With this, we are done with chapter 3. So we did chapter 1, chapter 2, chapter 3. We are done with algebra. So 10:30 ends here. No more 10:30. And now maybe I should start tomorrow. Yeah. Tomorrow we are going to start trigonometry, the fun part of this class, trigonometry. But it's all rules. You have to know all the rules. You understand? No? I love trigonometry personally. So have a good day. Here. What I did? Yeah, you. A lot, right? Where do you see y value for this scenario? Less than 0. What does less than 0 mean? Negative. No, negative y value. Simplify that 0 y value or negative y value. Just that. Now you found these x-intercepts. So you plug them on the number line. And then I was suspicious. I was like, why is there no number line? You have to make the number line. And then test the fast interval at least. Where you see they all have odd multiplicity. Means if you find the fast interval, all the sign will alternate. You still have the second exam and the final exam and your second quiz. And are you doing your homework? Yeah, I did homework. How do you pass? Like, what's passing? 16. Can we pass? I think for this one, I got the answer, but I just got the sign. I was wondering if you could give me the last point about something like, yeah. I have to punish you because your factors are wrong. I have to punish you somehow. Okay. It's not perfect, right? For perfect, you get perfect point. Yeah. It's not perfect, but coincidentally, you got 8. But if you, first of all, this is what you expect. This is 6, 5, and 8, and 6. If you put -6, then it's positive 6. Yeah. From -6, how can you still get -6? So I was looking at this. And if you get -6 here, then how come we didn't get -8 here? See, you did this one correct, you did this one wrong. Yeah. But you are the same, the minus. You need a punishment. Okay. Be careful in the next one. We cannot combine them because 3 here, we have from here to here these y values. And then suddenly from this number to this number, there is no more graph. How can you combine them?
So where does it start and stop the next one?
What's the y value from here, the bottom part?
Negative 4 to 3.
Good. And then what's the y value here?
From 4 to 7, 4 to 5.
I said y value, what you're talking about. Oh, it's up here.
Yeah,
So see, it's from -4 to 3.
5, then from a 4, there's nothing between 3 to 5, and suddenly 5 starts. So 5 and what's the last one really?
Yeah, so easy.
So 5 included, 7 not
Okay,
included.
yeah.
Be careful.
I know my friend,
But you still have your second name wrong.
no, I just want to say basically, oh yeah, I took this class last semester and I
I mean,